Hello and welcome to Analyst Crossfire, a Supercomputing 2011 wrap-up show featuring expert voices from the supercomputing community, giving their reactions to some of the top HPC trends as discussed at this year's conference. I'm Addison Snell with Intersect360 Research, and I'm your moderator for Analyst Crossfire. Joining me on the panel today are two vendors and two users who volunteered to share their opinions on any supercomputing topic I care to throw their way, giving us their personal views and not necessarily those of their organizations. Representing the HPC vendor community, first I have Peter Ungaro, who's the CEO of Cray. Good afternoon, Pete.
Hi, Addison.
And next we have Donald Becker, who's now the system software architect at NVIDIA, whom many of our audience will recognize from his role in the creation of the original Beowulf clusters. Don, thanks for joining us.
Thank you for having me.
From the supercomputing user community, down at the end, we have two highly esteemed representatives from prestigious HPC sites. Down at the end, I've got Earl Dodd, who's now president of Ideas and Machines and recently the executive director of Rocky Mountain Supercomputing Center. Welcome, Earl.
Thank you, Addison.
And finally, an old friend of mine, the manager of the HPC lab at BP in Houston, Keith Gray. Good afternoon, Keith.
Thanks, Addison.
Panelists, thank you all for joining me for the SC11 edition of Analyst Crossfire. The clock is running. Let's get started. Our first topic today looks at the systems we use for HPC, where many of the component technologies have continued to follow a commoditization trend. Panelists, to what extent do we need specialized supercomputing architectures, and is there a sustainable market need for them? Don, I'd like to start with you.
Oh, a little bit out of order. Definitely the commodity market's going to be driving all of the innovation, and the supercomputing industry just has to figure out how to leverage the commodity market. I see the really interesting spots in the commodity market, and of course I'm working in those areas because that's what I see moving forward. GPUs, architectural innovations are proceeding at a rapid pace there, mostly hidden from the end user, lots of interesting architecture changes going underneath. And from the system architecture point of view, mobile processors. Aggressive power management, really interesting structures for that. That's what's going to be driving things forward.
Pete Ungaro, commoditization is going to drive all the important change in supercomputing. What do you think?
Yeah, I challenge that one a little bit. So I think about it on a time scale. I think today you don't need optimized architectures if you're just running a lot of small jobs, a lot of easy jobs. But if you're running very large jobs or a lot of even very complex jobs, I really think that optimized architectures are getting now very important today, but actually growing in importance in the future, especially as the balance starts to shift where the individual processor or node is getting so heavyweight as we go forward, especially as we look out over the next 10 years or 5 years even, that the balance of the system will just get so out of whack that optimized architectures are going to be the only way to go. Except in a bifurcated market. So I believe you're going to have a system where it's a cloud or a Cray. Optimize at the high end, everything else on the cloud.
Hey, Earl, coming from the perspective of someone who not only is buying things for a research supercomputing center, but also interested in driving technologies into industry where you spend a lot of your effort in the missing middle, what do you think? Which of these are you going to buy?
I believe, because I've taken the hit on all fronts here, I believe it's closer to what Pete is talking about. It's his a multi-prong approach. I look at it more from a macro perspective. In there, I believe that there'll be tier 0 kind of class machines, a demonstration and provocation machines, and a tier 1 machine that basically moves on or along the commoditization realm. And then eventually you get into the cloud or the enterprise class type machines. So I believe there is sustainable models. I believe that there will be commoditization on one end. That will definitely move into the cloud, and there'll be something called an HPC cloud. And we've been able to demonstrate bits and pieces of that, but eventually you will still need very specialized heterogeneous architectures.
Now, Keith, you've pushed me on this exact topic going back to when I was on the vendor side, looking at what you will and won't buy as a manager of a huge commercial supercomputing center. What are you looking for?
We're looking to accelerate the creation of new capabilities. We want to generate a competitive advantage for BP exploring and developing oil and gas resources. And if paying a premium to create capabilities is justified, that's what we're willing to do. We want to create that competitive advantage.
Don, I'm going to give you a chance to get back into this, but first I'm going to point out that at this year's Supercomputing show, we counted 10 different processor architectures that were an active part of the HPC discussion. I'll quickly say Intel as Sandy Bridge, and they're also debuting Knight's Corner. AMD launches Interlagos and is talking about Fusion. Jensen's given the keynote with Tesla, and he's talking about ARM. IBM launches Blue Gene Q with Power. Texas Instruments is jumping in with floating point DSPs. You got Convey and a few others pushing FPGAs, and the number one supercomputer on the list is running Sparks, right? So we got a lot of choices out there. What's an application programmer to do here in this going forward?
I don't think the application programmer cares much about the underlying architecture. They care about the language and how it expresses the parallelism, how easy it is to use, and the underlying architecture needs to run that. It needs to reflect the language, or at least be able to run the language. Too many architectures out there. Some of those are clearly not going to make it. But again, I think commodity market will drive.
Which one's clearly not going to make it, Don? Give me one that's clearly not going to make it.
You know, I would have said Spark, but they're number one on the list.
All right, then. Pete, what do you have to say?
I agree with Don. I think we have to work really hard to make applications portable amongst all these architectures, because I do think while not all of them will make it, it will take a while to play out in the market. I think it's the most exciting part and big change in the market right now is all the different options that are out there. And as a system providers, and I think we have to really work very hard to allow people to leverage these different commodity processors, but not have to change their code every time.
Keith, what do you think of all these choices? Place your bets.
We don't want to turn geophysicists into computer scientists. We've got to have architectures that are easy to program and can provide a level of performance to let them try their ideas. So I agree with Don. We've got to try to hide some of the complexity, and we've got to provide tools for the computer scientists to go in and optimize to do that effectively.
Earl, last word on the topic.
Yeah, I long live Fortran, and I believe it will work. Okay, I believe that as a systems programmer and also as an application programmer, it's a complete nightmare, and it cannot keep up with the plethora of stuff out there. We've got to actually start doing some better jobs of creating different toolkits and frameworks and using more of a meta management layer on top of this to provide this level of information to these tools.
Yeah, Intersect360 Research believes we will start to see a resurgence in some of these specialized architectures, especially at the high end. Thank you, panelists. This leads us directly into our next issue, which is software specifically, new architectures, accelerators, multi-core, cloud. All of these imply some type of evolution in software. How badly do we need software innovation, and where's it going to come from? Earl, I'm going to start with you this time.
Yeah, so I believe we're extremely desperate right now for software innovation, although I believe that that is only the second largest problem. The first largest problem is people and skill sets. We actually don't have enough people coming in through STEM's education programs to actually be able to create a decent software infrastructure environment, let alone the hardware systems. And for national security reasons and for economic reasons, we should definitely be looking more at the STEM's education and the ability to basically create skill sets out there. With that said, the software is one of those big limiting factors out there, and without people, we're not going to actually make changes in software.
Keith, as far as we can tell, the oil and gas industry has possibly the highest rate of algorithmic turnover compared to all the other vertical markets. What do you think of this software issue?
I think we're going to likely live in a Fortran world. We've got to do a better job of providing modules and data sets, parts of code that can be reused and not have to reinvent everything. But clearly our whole effort is around evolving the code. And it moves pretty slowly. So it's a real challenge for us.
Don, what do you have to say there? You're hearing the end user needs in software.
Well, I think we need, I think Fortran won't do it in the future. It will definitely be around because it has been since the beginning of time. We need a language that can express parallelism, and it's not clear. We're moving there. It's going to take 5 to 10 years to introduce any language, so you should look at the ones that exist now and see how they'll evolve and push those to evolve faster.
Beginning of time on a Unix clock is January 1st, 1970.
Before the beginning of time.
Pete.
Well, we're clearly moving where there's going to be millions and even billions of threads that we're going to have to keep moving. So the parallelism is a growing thing. We have to do it. I think we have to get where it's not performance, scalability, or productivity, pick any two. I think we have to really work very hard to not give up on any of those three things as we go forward.
My partner, Chris Willard, was noticing this week that sometimes there seems to be this implicit assertion that any application could be made more parallel if we just made embarrassingly parallel, if we just work at it hard enough. You know, one metaphor I heard is that we ought to be able to get 9 women to be able to produce a baby in 1 month. There's always more parallelism to be found. When will we reach limits in how, practical limits in how parallel we can make our applications, Earl?
We're already there. I think we're already hit some of these limits. And the definition comes to what do you consider HPC or supercomputing? You know, whether, I mean, I think this last forum talked about whether, you know, online gaming is a supercomputing application or not. I believe we're already there. We're already in this crisis, and we really got to look at some radical revolutionary ways to approach this.
We count online gaming in our forecast because of the real-time I/O component. I'm going to come back down to the vendors. Pete, what do you think?
I don't think we're there yet. I'll go against Earl on this one. I think
I knew I could count on you.
There's a lot of opportunity to exploit more parallelism. I think we have to think about it in different levels and exploit it in different ways at different levels. But I think that there's a lot there. But it does go back to Earl and saying there's a lot of software innovation that has to happen. But I do agree also with Don. It can be evolutionary. It doesn't necessarily have to be revolutionary on that front.
Is that where you're sticking with, Don?
Pretty much. I think the parallelism problem, the Amdahl's law problem, is overblown. If you can't find the parallelism, if you can't do it on more parallel machines, you define away the problem, you don't do those problems.
Keith.
So we have a very parallel problem. And we're fortunate we have almost an infinite number of shot experiments in seismic data. And so
what number is almost an infinite number?
Millions.
Okay, that is almost infinite. You're right.
Not quite billions, but the requirement of allowing a researcher to try one experiment as rapidly as possible still means we need a very fast computer.
Now, part of our research is looking across the HPC industry at how they divide up their budgets. One area we're seeing is programming services is coming up. Not only how much people are spending internally on programming, but we could see programming services or even a resurgence in some of the federal systems integrator business, especially as we look at some of these specialized architectures coming forward. Thank you, panelists, for your views. I got one more third topic in our long format. This is the long format you're getting right now. One of the market opportunities discussed by many of the technology vendors, discussed by us as analysts while we're here at this year's conference, is big data. What does big data mean to you? How real is this phenomenon, and how does it relate to HPC? Keith.
So for us, big data means getting a call on a Friday afternoon from one of our researchers who asks, can we provide him with half a petabyte of storage for the intermediate results he wants to create that evening on a highly critical project.
Can you?
We did. And so when I went bike riding the next morning with the lead systems architect, the project was already finished and he was starting to analyze those intermediate results.
So Keith's got a big file view of big data. Earl?
Yeah, I look at it a little bit differently. I come from the spook side of the shop looking at this, and I don't like the word big data. I like to use extreme data.
Okay.
Okay, extreme data. And I'm not talking about the XD project attack and everything. And I expanded, several people's view of big data. I call it the 5V: volume, velocity, variety, variability, and value of data. And you have to look at all of those different aspects. Those aspects define what extreme data is about, those characteristics of that. And any of the real-time or near real-time analytic processing, from whether it was gaming or smart grid, seismic processing, et cetera, is all around extreme data.
Pete, you're hearing two traditional supercomputing users' views of big data. How does the vendor view of this differ?
I think big data is defined as a source of the most press releases per vendor at this point in time. So it's I agree with both of them. I think of it very similar to Earl in that it's data of high volume, wide variety, and you got to do it at high velocity, and that's all performance along with that. So I really think it's about gaining knowledge out of that, so doing analytics on that data. So it's more than just storing it or processing it and creating it. I think it's trying to get knowledge out of that. And really trying to understand if the data if the problem can be partitionable, how complex the queries are. Those are the challenges that we got in front of us.
Don, big data.
From the HPC side, it's continuing that straight line, the semi-log graph, just filling in the dotted part into solid, continues the straight line. The new side is all the search companies, all the other companies that we don't even hear about yet that are tying together order 40 graphs and trying to find correlations. And I don't think we've heard a lot about the techniques there. That's going to grow a lot. We'll probably hear real interesting things in science coming out of that, but we're not hearing it right now.
I think there are a lot of different dimensions to big data. Some of these are large file problems, some are many file problems, concurrent access to data, real-time I/O, computing and completing a computational analytics within the short lifespan of data before it rots. But I've heard some people proudly declare that HPC is big data, or vice versa, big data is HPC, and we've solved these problems already. Is that true, Earl?
No. The problems that I face are not true. I mean, just look at trying to just do sentiment analytics, and trying to read Twitter, or what YARP is trying to do now on viewing sentiment for Latin America. It's just not there. On the traditional way you defined it, speeds, feeds, file systems, inodes, and stuff like that, but I look at it from other dimensions like descriptive, going from descriptive to predictive to prescriptive type analytics.
Keith?
I see our requirements continuing to grow almost the same rate that our compute demand's growing. For bandwidth, for storage volumes, for being able to move data in and out of computers.
Is there anything in the enterprise side where they're talking about enterprise analytics that has a relation to what you're doing at BP?
Some, not as direct as our focus on seismic imaging and reservoir engineering.
Can the vendor side take some of the products they're using for traditional HPC and leverage them for big data applications, Don?
I think our customers are going to figure out how to do it. I don't think we know how to do it yet, not in the true sense.
Pete, last word's yours on big data. What's Cray going to do?
I think the way to attack big data right now is to really think back to the world of supercomputing, take supercomputing technologies, apply that to business intelligence, data analytics technologies, and try to bring those together to attack this problem. I don't think one or the other can do it by itself.
We think big data is a huge market opportunity for HPC technology vendors, but not in the traditional sense of saying, well, this is an HPC problem. It's just that a lot of the problems that come up with big data have some technologies that have been nascent in the HPC industry where they can be applied with the right go-to-market strategy. I don't think this is the last time we've heard about big data at supercomputing. Thank you all for your in-depth insights, but I'm going to squeeze in a few more topics with some quicker opinions as we go to our speed round. And Pete, I'm going to start a question almost directly aimed at you, although everyone will get to answer it. Cray had one of the biggest announcements of the conference winning the continuation of the Blue Waters project at NCSA after IBM notoriously backed away from it earlier this year. Is there a profitable business in building the world's largest supercomputers? Are you happy with this deal?
It's a great deal. I wish you'd talk more about it.
What are we doing here?
I would say I believe that at least Cray has proven that we can build a business out of building high-end supercomputers. The company has to be very focused and architected in a unique way. But if it is, I think it can be very successful in this market, not only in the market, but financially.
Don, is it profitable to build the world's largest supercomputers?
I had a friend who always used to say it all ends in tears, and it's really tough to make a business for the #1 machine. But there is a really viable market for everything below that. And if you can take the technology from the #1 machines, the top 10, the top 50 even, and move them into the rest of the top 500 list, yeah.
Fujitsu's productizing the next generation of K. They've already sold one. Keith, what do you think? You're maybe the largest commercial HPC site I've visited personally. Is that profitable business? Are you sticking it to the vendors?
I can help Keith.
Are you getting a good price?
I'm hopeful that the vendors are able to sell good systems to Exxon and Shell.
Do you think it's profitable selling them at the highest end of the top 500 list?
I can't tell from where I sit. I just know what our price performance decline curve looks like. I don't get to see behind their curtain.
You just get to tell people how much they get to charge next time. Earl, what do you think?
I believe that, are there business models out there? Yes. Are there profitable business models? I'm not quite sure. I hesitate to think that there are. I believe you have to define what profitability and sustainability truly means. And I believe that it's very difficult to do just a handful of machines.
I think the problem is we're spending so much attention on the top 1% of supercomputers. We're going to occupy top 500 when we're done here. But part of the problem with some of these high-end government systems right now, we've already been through U.S. and Canada having trouble with spending. Europe's going a little crazy right now. How much of an impact are global economic issues having on the HPC market? Should we be concerned? I'm going to start down with Earl.
Yeah, we should be concerned. It has had a significant impact. Is it going to have a continuing impact? I think it will. We haven't seen the bottom of what's going on in EU and Greece, and maybe that's a great place to put a whole bunch of supercomputers now. But I believe that we have to actually align ourselves both politically, economically, strategically to solve these problems.
Keith, global economic issues. You're a global company.
I worry about the consolidation of the vendors and whether we're limiting the creativity. I worry about risks that get created when all the disk vendors consolidate to one geographic location.
Don, is the global economic market affecting your financial outlook in the near term?
I'm very lucky at where I work that things are going quite well. I think overall the industry has had much less of an impact than the rest of the world has proportionally. But the part where we should worry about is all the low-end research that we didn't hear about that might have existed in universities but it's been killed. 2 or 3 years from now, that's going to hurt. I watched NASA when the funding was cut. All the expertise dissipated very quickly. That's happened in places, and that's a big investment that was lost.
Pete, global economy, what are you thinking?
Should we be concerned? Yeah, I think we should be concerned, especially at the high end of the market because it's such a small market that it can destabilize things. I don't think it's going to hurt the general part of the HPC market in the mid-range and low end. But scared, I don't think we should be scared. I think that there's drivers out in the marketplace. I just don't see a company or a country that could be competitive on a global scale without HPC.
Yeah, we're not only revisiting our forecasts, of course, at the top level, but reconsidering what percentage of that's going to be Asia by this time next year, as the other geos are struggling a little bit. Let's go to our last speed round question, which is an ultra-fast format here. Most predictions say the first exascale machines come in about 2018. About 7 years from now. Now, I don't want to talk about that first exascale machine. What I want to do is think about what the HPC market as a whole looks like 7 years from now in 2018 by the time we get to exascale. So start with, we talked about all these processor architectures. What is the dominant processor architecture in 2018? Is it x86? Is it an accelerated x86 like Intel Mike? Is it an ARM plus GPU, or is it something else? Pete?
This is the hardest question. I think it's some combination of an accelerator or heterogeneous processor by AMD, NVIDIA, or Intel. I'm not sure what.
You have no idea. Don?
Not a company viewpoint, my own personal viewpoint. I'm putting it on something that looks a lot like mobile phone processors combined with GPUs, and that probably means ARM plus GPU right now.
Keith, what's the world going to be buying in 2018?
I think we're going to be buying big processors with big capabilities.
Earl?
It'll be an ARM-like system.
ARM, 2 votes for ARM. What's the dominant system interconnect? Ethernet, InfiniBand, or something else, Earl?
Neither. It's going to be something else. I believe it'll be direct PCIe.
Keith?
I think it'll be called Ethernet.
Don?
I'm a huge Ethernet fan. I don't see that being significant except to connect to the outside world. It'll be something, InfiniBand will be showing its age, and there'll be something new like PCI.
Some successor to InfiniBand. Pete?
I think by that time the whole HPC market will bifurcate. It'll be all Ethernet on the low end and custom interconnects on the high end because of the bandwidth required, and InfiniBand will be the big loser.
Excellent insights. What's the thing else, Don?
I think something like CUDA or an evolution of it. C and Fortran will still be around. Languages don't change that.
Keith, programming language in 2018.
Fortran.
Earl?
I like Fortran, but it'll be a 6th-generation visual programming language.
Pete, what's the dominant programming language in 2018?
Fortran.
It's about a tie right now. C, C++, Fortran all come in very even at the top. Last one, I want you to give me a percentage of all HPC cycles that will be consumed in a public cloud model in 2018. What's the percent of HPC cycles run in a public cloud in 2018, Pete?
Well, like I said, it's a cloud or a Cray. I think about 30% on a cloud.
30% in the cloud. Don?
I don't think it'll look like a cloud. There'll be specialized HPC centers, and most of the cycles will be in HPC centers that won't look like the rest of the
That wasn't a
cloud.
percentage. Keith?
Less than 10%.
Less than 10%. Earl?
40% private, 10% public, 50% in-house.
There you go. Thank you. Isn't this fun? Thank you, panelists. We're running out of time on our program, but I always wrap up with one final question around the table. And it's the same question every time at Crossfire. I call this category one up, one down. As we wrap up SC11, I want each of you to tell me one thing that surprised you in a positive way. You got one winner, and I also want you to put one. That's the easy one. You also got to pick a loser. You got to tell me something that disappointed you. You were looking for more in this show. One winner, one loser from each of you. I'm going to start with Earl.
Yeah, so the winner, I believe it's the Barcelona Supercomputing Center with the ARMS prototype system and what they're trying to do with Mont Blanc. I think that's it. I'd also like to give a thumbs up to the Japanese people. They've hung in there.
That's two winners. Give me a loser.
Yeah, okay, but I wanted to give you two. And loser, I mean, I always pick Oracle as a loser, but but seriously, I'm actually disappointed that IBM hasn't open sourced GPFS yet.
Keith, one up, one down.
I'm happy that the industry is healthy and growing. I'm disappointed that we're not doing enough to create new people with capabilities, including computer scientists and the physical scientists.
Don, one up, one down from your perspective.
Luckily, GPUs are winning. Losers, the environment right now.
Going with NVIDIA as the winner. Proud choice. There you go.
Losers, the environment. High temperature machine rooms, outside air cooling, direct outside unchilled air cooling. We're not seeing any progress there at all.
I heard a similar loser to that from someone else earlier, going with energy efficiency. Interesting choice. Pete, last word's yours. One up, one down.
Well, I guess Blue Waters would be the winner in my book, but that may be cheating. So I'd actually say the winner is Lustre. I think we've seen a huge rejuvenation of Lustre around OpenSFS and a lot of products now around
including
Lustre
one from Cray, I think I noticed.
Yeah, you should buy one of those.
Loser?
And then the loser, I would say actually no change in the top 11 systems on the top 500. I think that's not a loser for overall, I don't think it's a bad thing, but I think it's just bad because of the vibrant of the sea of the community. So I think that's a shame.
Most interesting new system is the blue light Sunway system, all Chinese technology coming in at a petaflop at number 14. Thank you, panelists. That concludes SC11 edition of Analyst Crossfire, and with it, that's the end of the Supercomputing 2011 conference. I'd like to invite our audience to look for Analyst Crossfire again at the conclusion of the HPCC conference in Newport in March, the ISC 12 conference in Hamburg, and of course Supercomputing 2012 from Salt Lake City. I'll be joined by other panels of experts on new sets of HPC topics. I'd like to again thank my panelists, Pete Ungaro, Don Becker, Keith Gray, and Earl Dodd for joining me and sharing their insights, as well as the SC11 Steering Committee and organizers for another successful supercomputing conference. For Analyst Crossfire, I'm Addison Snell, Intersect360 Research. Thank you.